So let's take a look at the following examples. What if I ask you perform the operation and simplify your operations? 2 times negative 4x. Do it on your own. Remember what 2 times negative 4x means. 2 copies of negative 4x added together. So you'll have negative 4x plus negative 4x, which is equal to negative 8x. What if I gave you the following next problem? Answer true or false. Is negative 2 times negative 4x the same as if I were to take the negative 2 and distribute it negative 2 times negative 4, negative 2 times x? So tell us whether this is a true statement or a false statement. Can I distribute the negative 2 across? So negative 2 times negative 4, negative 2 times x. Pause the video, answer the question before moving on. Did you pause it yet? It's important you spend a little time thinking about this problem because it's going to help you later when we are doing more complicated problems. So think about negative 2 times negative 4x as additive inverse of 2 times negative 4x, which we've done here. So our answer should be the additive inverse of negative 8x, which is 8x. Versus here, you're going to get negative 2 times negative 4 is 8. 8 times negative 2, negative 16x. So it's clearly false. Multiplication does not distribute over multiplication. Multiplication only distributes over addition or subtraction. Please keep that in mind when you're solving problems. In the next example, see if you can explain what properties allow me to say 3x times negative 5x is the same as negative 15x squared. So that previous question was your video log question. I forgot to mention that. All right, so before we talked about 59 apples minus 26 apples, what would we do? We knew it was not practical to count down. So we can think of 59 apples as 5 boxes of 10 apples and 9 loose apples, like we did when we were doing addition. 26 apples as 2 boxes of 10 apples and 6 loose apples. So 59 apples minus 26 apples is going to be 3 boxes of 10 apples and 3 loose apples, because we have 9 loose apples minus 6 loose apples will give you 3 loose apples. 2 boxes of 10 taken out of 5 boxes of 10 will leave you with 3 boxes of 10. Or you can think of 59 minus 26 is 33. But now what if I gave you 53 apples minus 29 apples? In the same process as we did before, we have 9 loose apples, but in 53 we only have 3 loose apples. So in order to do the subtraction, we're going to have to take the 5 boxes and break them into 4 boxes and open one box and make 13 loose apples, 10 from the one box plus 3 here. So it will look like this. You're taking the 5, making it 4 boxes, taking the 10 loose apples and putting them here. So instead of 3 apples, we have 13 loose apples. So you're subtracting 9 from it, which will give you 4. And then 4 boxes minus 2 boxes will give you 24. And that's how you do decimal subtraction. You borrow a set of 10 to make this bigger and then do the subtraction. So 53 minus 29 would be 24. In general then, standard algorithm to subtract any decimal numbers would be match the place value. So let's say 679.43 minus 287.56. So line them up. Now 3 minus 6 can't do it, so we'll have to borrow 1 from here. And so borrowing 1 is borrowing 10 singletons or 10 100ths. When you borrow 1 from 10th place, you're borrowing 10 100ths. So 13 minus 6 will give you 7. Can't do 3 minus 5, so we'll have to borrow 1 from the 9. So that'll be 1 single is 10 groups of tenths. So that'll make it 13 groups of tenths minus 5 groups of tenths will give you 8. 8 groups of units minus 7 groups of units will give you 1. 7 minus 8 I cannot do, so we'll have to borrow 1 from here. So 17 minus 8 will give you 9. 5 minus 2 will give you 3. So that's how you do subtraction. When you can't subtract, this number is lower than that number, you want to borrow 1 from the previous one. So for video log questions, think about what to do if there is no digit on the left to borrow from. For example, 17 minus 56. I can't do 1 minus 5, but there is no number to borrow from. So explain what we should do then. So another way to look at decimal subtraction is to look at the number in the expanded form. So let's take our number 587 minus 321 and write it in the expanded form, and you will see that each unit, 5, 8, and 7, belong in their appropriate place values, and then we can do subtraction in the following way. We can do 5 minus 3 times 100, 8 minus 2 times 10, 7 minus 1 times 10. So we're basically doing same units again and doing subtraction of the same units. You're taking units place, tenths place, hundredths place, and then performing the subtraction, giving you 266 as your answer. Since polynomials behave very much like decimal numbers as we've seen before in addition and multiplication, we can do the same process of subtraction with polynomials, except we can't really borrow 1 from the previous because we don't have the same principle where one group of 10 square will make 10 groups of tens. We can't have that. So take a look. If you have this problem, again, you'll have x squares together, x together, units placed together. If it was 3 minus 5 here, since there is no carryover or borrowing, it would just be a negative number here. That's really the only difference. So you just take like terms, make sure the same units, and then do the subtraction. All right, so let's see. How can we do this? Again, you have seen problems like these before, and so let's take a look at the first one. You will see that that would just be same units, so it'll be 3 minus u minus v together, a plus b's. In the next, so a plus b is our unit basically. How about here? Again, same units together, so we're going to have to do centimeters together, centimeter squares together. 9 minus 4 will give me 5 centimeters. 6 minus 2 is 4 square centimeters. Centimeters together, centimeter squares together. In the third one, we'll have to change, convert. So we have 3 kilometers is the same as 3,000 meters, like we've seen before. 7 meters and 200 centimeters is 2 meters. And now they're all in meters, and so we can solve this problem accordingly. Do the last one on your own. Pause the video and then check if you got the right answer. I will give you the answer in just a few seconds. Assuming you tried it on your own, see if this is what you got. So you should have gotten 625.3 centimeters. And you can see why 6.3 meters is 630 centimeters right here. So take a look at what happens when you want to do subtraction and you're no longer in the decimal number system. Same principles that you did when you were at adding apply here. In adding, you had to watch for what to carry over. Now you had to watch for what to borrow. So for example, if you have 4 feet 3 inches minus 2 feet 7 inches, or 12 hours 23 minutes minus 6 hours 35 minutes. You can see that in the first example we have to use 1 foot is 12 inches, and in the second one we have to use 1 hour as 60 minutes. So in the feet and inches example, 4 feet and 3 inches, we cannot subtract 7 inches out of 3 inches, so we have to borrow one. So we'll make that 3 feet, and when we borrow 1 foot though, we have 12 inches, so we end up with 15 inches here. Minus 7 will give you 8, and then 3 minus 2 will give you 1. So our answer will be 1 foot 8 inches. How about the 12 hours 23 minutes minus 6 hours 35 minutes? Try that on your own. Pause the video and then check if you got the right answer. Don't just immediately look what the answer is. Do it on your own, please. So assuming you've done the problem on your own, it will look like this. So we have 12 hours 23 minutes. We cannot subtract 35 minutes from 23 minutes. So you're going to get rid of 12 hours, make it 11 hours, borrow 60 minutes, make that 83 minutes, minus 35 will give you 48, and then 11 minus 6 will give you 5. So our answer would be 5 hours 48 minutes.